All right, so Pomsy, we good? All right, so discussions. Overall, outstanding job. You guys, on the first round of discussions, you did a fantastic job. Really good answers, really good kind of discussions and replies between people. Nobody was like belittling or making anyone mad, so I thought you were very good about it. Typically, you all did the same thing of, oh, very good point. Let me add one sentence to that. But that's fine. You guys did really good. All right, so on Wireshark, so the discussion. What can we use Wireshark for network management? What are some things we can do with it, and why do we use it? Raise your hand, please. Everyone knows the answer because everyone posted something on it. So what were some of your answers? What's your name? Ashutosh. Okay. Okay. So number one, I think as a network engineer, troubleshooting is what we use Wireshark for. Okay, absolutely. Shweta. Okay, what about monitoring the traffic?
The packets which we receive.
Okay, absolutely. So number one, or arguably for me, number one, troubleshooting. Number two, analyzing packets, monitoring the network. Lady?
Establishing a like running a diagnostics or tweaks, for example, to be able to manage the network.
Okay, very good. We'll talk about this today. So she said, get a baseline for the network. Does anybody know why we would do that, or what the point of that would be? Why do we want to get a baseline for our network? What does that mean? Rahim. Absolutely. All right, so we're going to go into this in detail either this week, today, or next time. But we want a baseline of our network so we know what's normal. Therefore, if something is abnormal, we know what's wrong, right? So we can go look at that immediately. What else? Wireshark. What's your name? Soham. Okay.
So, like whatever data we get, we do whatever we want. So to analyze it further, so if you packets, you use the display filter. Actually focus on that and identify if there is any problem.
Okay, so we can focus on literally any kind of packet in our network. We can narrow that down for sure, for troubleshooting, for analysis, whatever. Forum? Very good. All right, so another major purpose with Wireshark is security. Okay, we'll talk about that today as well. Most of that stuff. All right, so then Nmap. You guys, again, were very good on Nmap. So what is it? The post was about ethical hacking. What is ethical hacking versus unethical hacking? Does anybody know?
Ethical hacking, basically it's not used for
Okay.
like just to analyze the network and just to know if there is any loopholes in that network itself.
Okay, so very good. So ethical hacking is not for malicious intent, right? So if we're not using it for malicious intent, how else would we use it? Why would we hack something if it wasn't to be a bad person? Aditya.
To find out the loopholes.
Okay.
With the system.
To find out loopholes. Why do we want to find loopholes?
And in the future it doesn't happen. If any malicious attacker tries to attack a network, that we can prevent it from that happening.
Very good. Okay, so the main point with ethical hacking is we want to find anomalies or vulnerabilities or loopholes within our system. And the purpose of that is if we find them, we can block them before a bad guy can exploit it, right?
We'd also be black hat hacking. For example, if a company hires you and says, okay, we've been hacked, but we can't access our network now. So he's counteracting it by hacking the network.
Sure. So yeah, that's a whole counter hacking culture. We'll talk about that when we get going. Yep, good point. She said white hat versus black hat. Has anybody heard that term before? Do you know what the difference is? Yeah. Sure. Very good. Yep, she added gray hat in there. So if you think of a black hat, you think of them as a bad guy, right? If you think of the Cowboys always wore black hats, apparently. But if we remember the Mirai botnet that we talked about last week, I mean, essentially what they did was they ran nmap for anything on port 23. Is there anything open on port 23? Then they wrote a very small Python script that said, okay, here's all the IPs that have port 23 open. Now let me just send them the default username and password for the top 20 devices. That's it. Like, that is super easy. We could do this in a 10-minute lab. And obviously, none of us would do something malicious like that, but you could do that. That's all it is. All right. So the difference between Black Hat, they're doing these tools to exploit, to get money, to do something that way, whereas everyone in here is doing it to protect our system. Something else, lady? Your matrix post was amazing. I never noticed that in there. And network discovery. One thing with Nmap, so network discovery, when you discover the operating system, why would we care what operating systems are on our network?
Because we can know the loopholes of that operating system, and then it can be vulnerable. Absolutely.
Perfect answer. So if we know what OS is on our network, we can know what vulnerabilities are on those OS. So are they running Windows XP Service Pack 1? Okay, well, we know what vulnerabilities are there. Are they running Ubuntu 12.2? Well, that's open source. We know every vulnerability that's there. So the benefit of knowing what OS is on the network is you can patch it if you want them to be fixed, or you can attack it if you were the Black Hat. Overall, fantastic job on the discussions. So we'll just do that same thing every week, but as your first post, almost everybody did really, really well. All right, so today, network analysis, probably Wireshark will be Wednesday or Thursday. All right, so network analysis, like we talked about. So we're listening and analyzing traffic on the network. Right? We're analyzing the network for analysis. One of the very key points of network analysis is it needs to be non-intrusive. Why would we want our network analysis to be non-intrusive? Rahil? Okay. We don't want to be looking and analyzing our traffic and changing it at the same time, or there's no point in analyzing it, because we would be creating a variable that's changing. Right? So we just want to be a pass-through device that just listens on the network, doesn't change anything. Now, network analysis, I said you have to know what a router does, what a switch does, what a router does, firewall, as well as how all these technologies work. Why? Why is that important? Why can't we just monitor the traffic and use that however we want?
Better understanding of what's.
Okay, how so?
Like in Wireshark, if there are some packets of UDP, then we know of TCP, then we can know, that a 3 handshake is going on.
Okay.
So, things like that.
Okay, so TCP is a good example. If we're using Wireshark, if we know that TCP has a 3-way handshake and we're not seeing that SYN ACK, we know something's wrong. Okay.
And for that, you have to know how they work.
Okay.
At what point does information flow and you can actually see it.
Okay, very good. So where you're listening, so where we place our analyzer is very critical. If you think of the difference between a switch, router, and firewall, depending on where I analyze that packet, is it going to change? I hear some yes. Why? Why would it change depending on where everyone says yes, but why? Why?
For example, if there is a NAT happening at the router,
Okay.
then the address that is behind the router would not be seen outside the router.
Perfect example is NAT. Right? If I'm listening on the inside of my router, I'm going to have private IPs. If I put that same device on the outside or the public-facing side, If it's NATed, I'm looking for an address that's no longer there because it's been translated. Yep, very good.
Even layer 2 addresses will be changed, like after the router.
Okay, so we'll come back to that. Great point, all right? So the difference between layer 2 and layer 3, what do we use at layer 2? MAC address, right? And at layer 3, we use IP address. All right, so if we're looking for a specific MAC address, if it traverses a router, are we going to see that? Yes, no, maybe? No, definitely not, right? Because the router is going to source it with his MAC address. Okay, so that just depends where you put your analyzer. We'll talk much more about this as we go. And then the thing I stress in all of my classes, whether I'm teaching telecom lab or in my other classes, the next generation SDN, know the technology more than remembering the commands. If I know how OSPF works or BGP works, it doesn't matter if I'm configuring a Cisco or a Juniper or an Adtran, whatever. As long as you know how the technology works, that's the most important thing. You can always figure out the commands to implement it. All right, so same thing in here. If you know how V6 works, if you know how DHCP works, doesn't matter what vendor you're using. So what we're doing with network analyzing and protocol analyzers. So when I say a protocol analyzer, you understand what that is? Pretty much the most common protocol analyzer is Wireshark, right? So all it does is it captures all these protocols. You can look at them, see what they're doing, right? That's a protocol analyzer. So what we're doing is we're locating faulty devices, right? That happens a lot. Okay, something's wrong in our network. Let's figure out where it is and who's causing that issue. It's not always devices. It can also just be misconfigurations. What would be an example of a DHCP misconfiguration? And how would we find that with, I'm going to use protocol analyzer and Wireshark interchangeably. How would we find a DHCP misconfiguration? Yeah.
Where people are allowed to bring their own devices.
Okay.
Let's say a person brings in a router of his own and he attaches to that system. That router will create a DHCP rogue point which will give out IP addresses. That's one kind of example of it.
Okay, so one right there is called a rogue DHCP server. Right? Have you ever heard the term of BYOD, bring your own device, right? In most companies, that's fine, right? You're going to bring your phone, you're going to bring your own laptop, but some people bring in their own little wireless routers. Okay, so what we could do with the protocol analyzer is we could say, my device is asking for DHCP, and 2 DHCP servers are responding. Well, that's not how our network's supposed to work, so we would know that somebody's misconfigured. What specifically would be a DHCP misconfiguration? So what you talked about was a rogue DHCP server. How could we find, or what would be a DHCP misconfiguration that we could see with Wireshark?
Maybe it's assigning the same IPs to 2 different devices or something.
Okay.
If it's going on.
Okay, good example. So if we're requesting address, and we look at our capture and say, our DHCP server sent an address that was already on the network. Or our DHCP server sent an address, a default gateway that's wrong. Okay, it's working right. The client requested a config or an IP address. He sent it. It was just wrong. We could see that in Wireshark. Okay. So if you ever work with vendors, Cisco, Juniper, whoever it is, if you ever work for one, Arista, if you are working for them, most of the troubleshooting is your device isn't working properly, right? They'll call up Arista and they'll say, yeah, the switch that you have is not working right. So you're going to put Wireshark in the network to see what's happening. So typically, if there's packet loss on the network, almost always it's going to be a device. Either device is configured wrong, port's bad, processor isn't strong enough, that kind of thing. Most of the time it is going to be a device somewhere in the network, and you can use Wireshark to determine that. All right, so with security and Wireshark, what is IDS, intrusion detection? Does anybody know? And how could we use Wireshark to do that? Just think of it pretty basic. So you're probably familiar with what intrusion detection is, right? There's an IDS and an IPS. Intrusion detection is we are trying to detect things that are malicious to our network, someone trying to intrude our network. How could we use Wireshark to do that?
It's the source IP address. The Wireshark, in the display filters, we can just see the source IP address and find that it's coming up from a malicious source.
Okay, so a good example is just filter on IP address. So we have Wireshark running and we say anything from 68.8.8.8, I need to be alerted that that's there. So that would just be an intrusion detection, matching on an IP address. Or we have a private government network. There should never be FTP traffic on there. We can use Wireshark to say anytime we see FTP traffic, alert somebody, do something. Okay? All right, so if we want to discover all hosts on our network, all operating systems on our network, and all the services on our network, where would we place, one place in the network, where would we place our packet analyzer? Let's say, so he says switch. What about, let's say we have 5,000 users in our network. Okay, so medium-sized business, 5,000 users. Is there one place we could put the protocol analyzer? Is there one place better than another? Or is there no way we can capture all the traffic?
The default router where it's or the place where it's netted.
Okay, so internet router. Okay, so internet router, do we agree or disagree? Internet router is a good answer. It's a good option. What may not work with internet router?
We can capture things within the network.
Okay, what if something's not going to the internet? What if it's just host-to-host traffic? Okay, so great answer. Another option, when else would that not work? Okay, so if we just place it in front of our internet router, it wouldn't capture LAN-to-LAN, intra-LAN traffic. What else?
Tell you the individual hosts because you will never know about the hosts that are there, the end hosts. That always that information is there.
Okay. Okay, so we may not know the individual host information. If we're using something other than Wireshark, we probably could. What else? There's kind of an obvious answer that you may be missing. Oh, you're saying put it on the DHCP server? Okay, so I'll give you a hint to the previous question, which is similar to that. So what we're talking about here is if we can place a packet analyzer somewhere in the network that it will capture everything. We said if we put it right by the internet gateway, it'll capture a lot of traffic, but it won't capture all the site-to-site, LAN-to-LAN traffic. Okay, so he says DHCP server. Okay, the other thing that we can't put it in front of a internet router is because with 5,000 users, do we just have one internet connection? No, typically we'll have multiple internet routers. We'll be load sharing, we'll be doing failover, something like that. Any other ideas or options?
On the edge device of our network.
I would say that's the same as the internet router.
Some device, some traffic.
Yeah.
Telephone link or
We still wouldn't get the site-to-site traffic, though. Any other ideas or thoughts or options? What else? Okay, so core switch, to me, is the best answer. All right, so put it somewhere near our core switching network. But the real answer is it depends what you're trying to capture and how much traffic there is. Okay, it's virtually impossible to capture everything in a network. Okay, there is just no way that all your traffic always touches one switch. All right? If your network is designed properly, it definitely should not do that. So what the point of that is, with a packet analyzer, you're going to have them in multiple places, okay, throughout the network, depending on what you want to capture. Some other things that you're going to use Wireshark for security purposes is for forensic data. If you need to capture certain traffic on the network for an extended period of time, use Wireshark for that. One thing to remember is if you're ever doing that, is anybody in security track? Not yet. So Professor McManus does this all the time, but if you are capturing something for forensic data, it's like required that you hash that, and you can do that in Wireshark. So you can save that file in an encrypted format so that someone else can't just open it and read everything that's inside of it. All right, a couple of security type things are these two. Rahil kind of mentioned them, but one of the major things, like in the enterprise network security class, that is a third semester for security students. So we did Cisco ASAs. So a lot of that testing is NAT, firewall, all that kind of thing. Number one thing is step one, if something's not working, put Wireshark on the inside of it, put Wireshark on the outside. That way we can determine if that firewall is blocking it as it should, or is it blocking something that it shouldn't. What about this last one? How would we know if something's encrypted, if it's supposed to be encrypted or not encrypted? Okay, so he says if it is encrypted, decrypt it. What we want to see is, how do I just know if something is supposed to be encrypted? How do I know if it's being encrypted? Is there any way I can test that?
Might be some protocol.
Okay, GRE, very good. GRE is not encrypted. There is a very similar technology that IPsec. Okay, so what typically for encryption traffic, we're going to use an IPsec tunnel. All right. So if we have a VPN concentrator or something that is encrypting our traffic, we would just put it in front of that and say, is traffic coming out of here encrypted? Okay. If that traffic is encrypted and we want to see what IP addresses are in there, can we do that? Yes or no? I see some nodded yeses. Anybody no? Nobody's got anything VPN related? That's fine. So in general, if something is encrypted, Wireshark's not going to show you anything. Right? If you need to troubleshoot something on a VPN, if you put your packet capture after it's been encrypted, you can't see anything. That's the whole point of it, right? We're blocking IP addresses, we're blocking port numbers, we're blocking everything. So source, destination, all that stuff is encrypted, therefore Wireshark doesn't do anything. All right, so that's one of the things that VPN is so good, goes over the internet. If anybody's using Wireshark or whatever, it doesn't matter. You can never see what's inside there. All right, so if we want to use Wireshark for optimization, so if we want to optimize our network for network management, network analysis, what can we do? So this one right here is very common. If we have a slow server, right? Let's say we have a web server. What port would it generally run on? Port 80? Yep. If we say our web server is running slow, let's put Wireshark in front of it. What would we be looking for? What are some things we might be looking for as to why that web server would be running slow? What? What?
Round trip time.
So round trip time, we can talk about that. Yep, we'll do that later. Did you?
You could see the congestion by plotting it on IO.
Okay, we can use IO graphs, which you'll do in the lab. What else? Forum. Okay, absolutely. Yep, so a very common, what you're going to do in this case is your TCP, you're going to look at your TCP traffic, you're going to look at your SYN, your SYNAC, are there resets, are they sending duplicates? This exact question was Facebook interview number 1 question. So basically, how would you use Wireshark to troubleshoot a slow server connection? So you say, is it a web server? If it is, okay, I'd be looking for TCP, SYNAC type stuff, and everything that you guys mentioned. All right, so we're also going to analyze bandwidth requirements. Okay, so why, when we're doing network analysis, would we ever care about bandwidth requirements of some application? Why would we ever care? Or would we ever care?
As a company, you're paying for a certain amount. Always exceeding the cap, charge extra.
Okay, absolutely. All right, so let's say we have a 10 gig internet connection, and we're going to add this very new feature in our network called voice and video over IP. Do we care how much bandwidth that uses? We do, right? Because if we add a bunch of video traffic on our network that's going out to the internet, maybe our 10 gig connection isn't going to be good anymore. So we need to know how much our applications are using. Also, on our LAN side, okay, if we have 1 gig switches and we add a whole bunch of traffic, do we need to upgrade to 40 gig switches? Maybe. Okay, so we need to know what our applications are doing so we can optimize our network. Any questions so far? So directly related to the question on the quiz. So when would Wireshark Protocol Analyzer, when would they be illegal to use? Like I said, technically in the US, they're always kind of illegal to use. But for us, it doesn't matter. Everyone uses it because you're not using it maliciously. Okay, so that's kind of the fine print of, as long as you're not trying to harm someone or steal information or do something with a negative impact, generally it's okay to use. But there is this, so if you think of ITP, right, we're interdisciplinary. This would be the policy part of network analysis. So there's this Wiretap Act which just says you can never do anything that would possibly hinder someone without them letting you do that on purpose. All right, so if we are capturing information, what are some of the main things that we would want to capture that would be kind of strictly prohibited? Okay, passwords. We can't steal passwords. That's, you think as network engineers, those are big deals. To policymakers and stuff, they're not so concerned about passwords of your router. Okay? What do you think of in a company would be very valuable? That what? Credit cards, absolutely. So credit card information is one. What else? So PII, just read the slides here, everyone. PII, HIPAA is, anybody know what HIPAA is? Healthcare industry, so your health medical records, right? All this stuff is very, very important to at least the US government of, these are things that you could all capture on Wireshark if you got on a network. So if, how do we prevent this? Okay, so step one, generally, this is illegal to do. As network engineers, if we are the network engineers for our company, how could we prevent these things? How could I prevent someone from getting on my network and capturing all my data? Right? That's our job as network engineers. We're responsible for our network, and in turn, everything in our company is digital. How do we make that safe? Anisha, thank you. Okay, encrypt traffic. We absolutely, if we encrypt anything, we can never see what it is, right? What would be the downside of encrypting all of our traffic? Time. Takes processing power and time to encrypt everything. Okay, so a lot of government agencies encrypt pretty much everything because they don't care how fast or slow it is. They just need it to be secure. What else could we do?
Firewall rules to ensure that.
Okay, like what? Okay, so she said firewall rules. So I would take that one step further and say, make sure all of our networking equipment has only ports that it needs. Right? So if we're not using port 80 on our web server, shut that down. If we're only using port 8080, allow that open. If we, on our Active Directory server, disable Telnet, those kind of things. Right? So that's just known as device hardening. Okay, absolutely, great point. Absolutely. All right, so port security, for those of you in Telecom Lab, you will do that if you haven't already. But one of the most common ways to capture information in a network is These little jacks on the wall everywhere. If you have a jack on the wall down in the lobby, somebody can just walk in, plug right into that, capture everything on the network. All right, so if you use port security, then we would only allow certain MAC addresses to connect, kind of thing. Could we take that port security one step further? Same concept, but could we take it one step further? Picture the open port down in the lobby. Okay. The command is shutdown on Cisco iOS. Shut down ports that aren't being used. Right? There's a lot of admin overhead with that because you have to manually go in and enable or disable ports. But in general, kind of best practice is shut down all the ports that you're not using. Only turn them on when you need them. On the 3 layers of switches, what specifically would those switches be known as? It's a vague question, but right, the ones that connect to ports in the lobby or ports in rooms, what are those kind of switches called? Access layer. Yep, access layer switches. Another one is common sense to hopefully everyone in here. On your wireless network, just have a password, right? If you don't, you don't have to sit in the lobby. You could be parked in the parking lot, and you can get on the network, right? Even though you may say, oh, my guest network, I don't need it to be secure. That may be fine, but anything that you can do is better than nothing. Okay, number one reason that people don't learn how to use protocol analyzers is this needle in the haystack. Have you guys ever heard that phrase or that term before? All right, you have this giant pile of hay and you're looking for one needle in all that. So that is typically a reason why nobody wants to use protocol analyzers. They're going to say, I'm going to capture all of this data. I'm not going to be able to define what I want. I don't know how it's supposed to work. So they just kind of shy away from it altogether. Any ideas on how to alleviate this needle in the haystack? I saw at least one person kind of posted on this idea. How do we get away from it? Right? So how do we prevent just having mass and mass and mass gigs of data that we have to sort through? Filters, okay. So filters, absolutely. In Wireshark, we use what's called filters. There are 2 kinds of filters. There are capture filters and display filters. When would we use one over the other? And why or why not?
Filter captures everything. Then want to look at the data.
Okay, so he said, when you for sure you only want to capture one kind of data. All right. The only downside with that, he's exactly right. But the only downside for that is, what if when you're troubleshooting, you think, I only am caring about DHCP. So you capture filter DHCP only. Well, then what if you decide that, oh, you know what? Actually, it wasn't TCP that was the problem. It wasn't DHCP that was the problem. It was TCP. You didn't capture any of that, right? If it's something that happens only occasionally, you may have missed your window to ever get that back. So display filters, use them all the time, right? You can use as many display filters as you want. You can focus on DHCP. Oh, no, that's not the answer. Let me look at TCP, or let me look at something else. But what is one of the very benefits? When would you ever use capture filters? So,
on a particular interface?
How so?
Maybe if you want to capture the data on a particular Ethernet interface or something, or the traffic coming on that particular Ethernet interface, we can use the capture filter for that interface.
Yep, so per interface, typically a capture filter is already per interface. So we want to narrow it down. It's coming in on Ethernet 1 or NIC 1. Why would we ever filter something even though we have already understood that we may be missing something that we need? Why would we ever use one then? No ideas?
Maybe we don't have security clearance for that amount of time.
Okay, absolutely, right? So if you go into your consultant, you go into business X, they say, you can capture on our network, but you can only capture layer 2 information or just IPs in the subnet or SIP traffic, whatever it may be. Yep, absolutely. The only other time I've ever seen it is exactly what he said, and the other one is if you're placing your capture in the middle of just terabytes of data traversing it, your PCAP file is just going to be too huge and it will crash the server that it's running on. So only if you're in a place where it is like, extremely fast traffic that is going to be used, you could use a capture filter that way. All right, a couple other ways to get around this needle in the haystack is colorize. You'll do that in the lab. So HTTP traffic, make it a color that's pink so it's easy to see. Add these expression buttons and profiles. Has anybody ever used profiles in Wireshark before? So it's kind of Wireshark does everything. It's like my favorite thing of all time. So what I will typically do is I will have a VoIP profile. So I can go and I know, all right, it already has SIP colorized as pink. It already has UDP traffic here. It's already matching this. I'll have a network engineering one that says, okay, colorize OSPF, colorize BGP, look at these kind of things. So what these profiles are, if I go in and I'm consulting for someone who's doing VoIP, I just pull up that profile and it already has everything that I'm looking for in it. I don't have to redo those, just like when we talk about automation. So we're automating this so we don't have to redo the same thing over and over in Wireshark. We're just getting those same kind of scripts within it. And we're going to do that in the lab. And this follow the stream, I saw a couple of you posted that on your discussions. That's very good. So TCP is a good example. So let me right click on it, follow stream, and now I see all these SYN, SYNAC, all that stuff. And then the other way is graphing. Who said the IO graph? Yep, we'll do that in the lab as well. So all of these reasons that a lot of people don't use Wireshark, we're doing it in the lab so you guys are proficient with it. All right, find the top talkers. We're going to do that in the lab as well. What are top talkers, first of all? What are top talkers? What does that mean? What is it on a network? Okay, the users using the most bandwidth are typically what it is. Why would we want to find them? Yep, okay, so one reason is we could see which of our employees is using YouTube at work. Okay, we can easily find that. Okay, what is one of the other more common reasons to find top talkers? So same reason, same concept, but think of it in a business perspective. What would we be trying to find, and why would we be trying to narrow that down to top talkers?
Could be a security issue.
Okay.
Sending traffic out.
All right, so exactly right. So security issue in the sense of if PC1 has a virus, you are going to see that thing just blasting out traffic, and you can easily say, oh, IP address 10.1.1.1 is just sending way more data than it normally does. Let me just go unplug that from the network. Okay, that is a very, very common for top talkers. What else would we use top talkers for? Amrita.
For cost analysis.
Yep, so a very good example of that is social media. Okay, so for top talkers in my business, not only do I look at IP addresses or source information, I can look at protocols. So I can say, what are the top talking protocols? Or one step further than that, what are the top websites that my employees are going to? And it's typically Twitter, Facebook, YouTube, Netflix. So we can automatically see if we shut these down at our company, we're going to gain X amount of bandwidth. And that's what a lot of people do. The other reason we want to find top talkers is kind of what Lady said, is our baseline. If we know that we have more web traffic than anything else, that's fine. But if all of a sudden we have a bunch of FTP traffic on our network, we know that that's not normal. Okay, so we want to get that baseline. We'll talk about all that in depth when we do network design later in the semester. Graphs, we talked about that. That makes it just easier to read. One thing in here, I'm sure almost all of you are taking VoIP Lab in the fall, right? Yes is the answer. So one thing that is extremely useful in Wireshark is we can capture conversations. Okay, so voice over IP is all on the network, right? So you plug in Wireshark, and you can just click on that phone call, right-click, follow stream. We see who called who, what their phone number was, how long they talked. But also what we can do, whoops, this is the next question. But what we can also do is we can audibly play their conversation. Any voice over IP communication on a network, if you put Wireshark in there and you capture the call, you can play the entire message, both parties, whatever they said. Okay, we do that in the VoIP Lab. So the purpose of that for troubleshooting is I have these two people talking. I can see, oh, this one sounds choppy, right? So it has bad audio quality, and then I can find out why they have bad. Is it bad cable? Is it something else? But on the other hand, you can listen to anyone's conversation on the network at any time. Does anyone see anything that may be bad about that? Yeah, right? Yeah, it makes you think twice when you're calling on a VoIP phone, right?
Isn't it encrypted?
Can be. Most of the time it's not. So he said, is it encrypted? So almost never is your VoIP calls encrypted. Can be, though, absolutely. So you can set that up if you want to. Again, what's the trade-off? It's a lot safer. It takes a lot more time. You have a lot more delay. You have to have devices that support encryption. So what do you want? If you're a network engineer, your argument is, what do you have to hide? So I should be able to listen to your conversations, right? Well, that's up to the company to decide. Okay, so when we're doing packet analyzers, protocol analyzers, we have to understand how the traffic flows through the network. So a couple things on a switch. Tell me some things about a switch. What does it do? What does it not do? How does it function? Mark, give me one thing.
It operates at layer 2.
Layer 2. Okay, layer 2. What does, Ankur, layer 2, what does that mean?
So it's forward the traffic based on IP addresses.
Okay, which are what?
MAC addresses.
Layer 2, so switch, layer 2, all we care about is MAC addresses. Anything else? Collision domain, absolutely. So they create collision domains. Do they manipulate traffic? No. All right, so that is very important when you're looking at your protocol analyzer. The reason for that is if you're troubleshooting a switch type issue, packet analyzer, we have no idea if it went through a switch, or 100 switches, or 1,000 switches. Okay, so when you're looking at your capture, we have no idea if there was any switches in there or not. Okay, something to just keep in mind when you're troubleshooting. Okay, questions on switch? What about, yep. Hmm? But where would you only see that VLAN tag?
So if you capture on the access port, then we'll not see one port we can see.
How would you, so what he's saying is we can see if it has a VLAN tag on it that it went through a switch somewhere. How would we physically capture that? We can't cut the wire in half. And when it gets to the other side of the switch, it strips that tag, right? So how would we see it? Span port. Yep, port mirror, span port. Yep, we'll talk about that later. Yep, that's a good point and good answer. Okay, what about router? Basic stuff. Layer 3 focuses on IP addresses. Does it change information?
Yes.
What? Okay, NAT. Okay. It'd be kind of a firewall function of a router. But what else does it change? Layer 2, right? It says it gets to the router and it says, now I'm sending out traffic with my source MAC address. Yep, very good. Oh, broadcast domain, you already knew that. Okay, last one, firewall. What does it change? NAT, we already said. What else? Could change port numbers, absolutely. So that would be PAT and it can change the IPs. Very good. All right, so the point of this is you have to know what each device in the network does depending on what you're capturing, depending on what you're troubleshooting, because it's going to interact differently through the network. Okay, basic stuff here, real quick. As far as we're concerned, does everybody know the OSI model? Does anybody not know the OSI model? If somebody didn't know the OSI model, would you tell me? Probably not. When we're doing Wireshark, which of these 7 layers are we concerned about? Data link, transport, network. Wait, I'm looking for one answer. Are these all the one answer? Did you say data link is your one answer? And yours is transport? Here, another transport? Another data link. There's no right answer. It depends what you're looking for. Okay? Are we looking at HTTP traffic? We don't care about IPs or layer 2 info. Are we just looking for MAC addresses in the network? We don't care about stuff on the application layer, right? So Wireshark's giving you everything. Every layer of the 7-layer model, you're going to get that information. What is the PDU at the transport layer? What? Segments. What about at the session layer? Nobody cares. All right, network layer, transport layer. What do we use to map the application layer to the transport layer? Ports. Yep, ports. Sockets, kind of, I would count that answer. Ports is what I was looking for. Okay, so now we're doing Wireshark, right? So a little bit, we'll give an overview on Wireshark. So overview before is protocol analyzers. It doesn't have to be Wireshark. Wireshark is just like exponentially the most common, most popular, rated the #1 open source app of all time. So, and that's because not only is it networking related, it's security related. So every networking engineer, if you do not know Wireshark, you should not be a network engineer. All right, so what we're doing is we're analyzing, troubleshooting, all these things we already talked about. Has anybody ever never used it before? Every single one of you have used Wireshark before. No way. I don't believe it. We'll see on the lab quick enough. All right, so one thing with Wireshark is it's a first responder tool. All right, what do I mean by that? It's a first responder tool. So you're a network engineer. Wireshark should be what? First responder tool. #1 thing you do, you throw Wireshark on the network and you start using it, okay? This is like the easiest, most definitive way to find issues. So whenever I'm troubleshooting with someone, I say, what did the packet capture say? Right? That's like step 1. We have to see what that packet capture says. One of the main common uses is to find bugs. How would we find bugs using Wireshark? How would we find bugs or software issues with Wireshark?
I see repetition.
Okay. Okay, very good.
Like if there's a bug, I mean, as you said, there's a virus that keeps on transmitting data.
That would be finding a virus. Yep. But what about like a software bug? How would we find, think of networking equipment. Yep, absolutely. So I worked for a vendor for a long time, right? When we would add train to a Cisco, a very common one was BGP isn't working, all right? Is it configured wrong or is it a bug, all right? What we would do is we'd use Wireshark in there. We would look at the BGP communications and we would see who is not replying to the specification, right? So again, you know the technology, You don't care about the vendor. So if I open up the BGP spec, the RFC, and I says it's supposed to do A, B, and C, and you're not doing that, you have a bug in your software. You've designed it wrong. I specifically remember that with Atran and Cisco and BGP ASNs. Okay, that's very common, right? So if you know how it's supposed to work, you put Wireshark in between. It happens all the time with two different vendors. Right? They say it's the other person, they say it's the other person. You put Wireshark in the middle, and it's kind of like this demilitarized zone that says, all right, I'm listening. I don't care who says it. I am unbiased in the middle. And this is the most important thing. So we're looking at what's actually on the wire. So think of the Cisco to Juniper connection. Okay, let's say we have a BGP, or let's say we have an OSPF problem. OSPF isn't coming up between the two. Can't form a neighbor relationship. So why would we want to put Wireshark in there instead of just looking at the configs or the debugs? Okay, what about it? Okay, so that's true, but we could typically see that in the debug, right? Debug IP OSPF on Cisco, we'd be able to see the negotiation, the TCP setup, all that stuff, right? Why would we want to see what's actually on the wire instead of using Juniper's debug and Cisco's debug? Okay, so we could see both sides, absolutely. Sometimes your debug, you're going to see what was sent and received, but in the middle, like physically in the middle, we're going to get both sides of that conversation. What else?
Format of the pattern.
Okay, how so?
Like, are they using proper bits, the RFCs, in the correct order?
Okay, so a lot of times you can see more in a packet capture than you can in a debug. I'm looking for kind of something specific.
To check what the device is actually.
Yep, very good. All right, so one of the main things are whether it's two vendors or the same vendor, doesn't matter. But if you put a capture in the middle and you see what's actually on the wire, debugs can be wrong, right? Depending on Cisco iOS version, the OSPF debug may not capture what you're looking for. Or it may capture it and say it's sending it, but it's not actually on the wire. You can't always trust debugs, but you can trust what's actually on the wire. If your router says it's putting it out on the wire, it says received and sent, you don't really know that. You just trust the debug. Why would a debug be wrong? Why would a debug ever be wrong? Or would it ever be wrong? What? Software, right? Anyone who programs software knows that there can be bugs in code. And a lot of times debug is one of those things that happens the most because they're like, it's not important to this thing working, we'll just kind of throw this debug code together, right? So maybe not Cisco and Juniper, but if you think of maybe a lower level vendor device, yeah, maybe so. Okay, so the code isn't always right. What else? Any other reasons that debugs may lie?
It's a cross-vendor problem rather than debug.
Okay, absolutely. Maybe it's a part that doesn't matter from bringing it up, but vendor B doesn't support that part of the RFC, even though OSPF still works. It just doesn't care about that one part, so it would ignore it, so it wouldn't see it in a debug. Yep, very good. A couple others are, what if there's a bunch of traffic and it just can't process it fast enough? Typically, most vendors say debugs get lowest priority based on their processor, right? So I'm going to send an OSPF hello before I'm going to process that debug message. So if you're looking at debugs, maybe if it's overprocessed, you're not going to get all the messages that you want, whereas if it's on the physical wire, you're going to see it. So for those of you who have never had, hopefully, I'm going to give you a little bit about the technology, but most of it I'm trying to apply to what you're actually going to see in industry and in your job. Right? This is how you're going to use this stuff. Hopefully that's what you'll remember when you get out in the workforce. So the last thing, so I am a huge proponent of certifications. However, this is one that I do not recommend. So there's nothing, I don't have anything against it. I just think it is way more involved than what you're ever going to need. Does anybody have it? Anybody? I mean, it's absolutely wonderful if you have it. It's just not one that I would pursue if I were you. I'd pursue a bunch of others before that. That's my opinion, though. There's a lot of other people that will say the same or differently. Any other questions so far on Wireshark protocol analyzers? Let's stop there for today. All right, so we'll stop there for today. Sayushni, is the lab posted yet? Do you know? No, it's not, or no, you don't know? It's not. Okay, we'll post the lab that starts this week today after class. Let me know if you have questions, and we'll see everybody on Wednesday. Thursday, whenever this other class is. Thank you.